Let's look at these questions now. For how many positive integers n is n cube minus 3n square minus 3n plus 27 less than 0? Less than equal to 0. Of course, again, a cubic expression, we don't know how to solve it. So we plug in values. So when we plug in values, 1, does it work? For n equal to 1, I would get 1 minus 3 minus 9 plus 27. No, doesn't work. For n equal to 2, 8 minus 12 minus 18 plus 27. No. For n equal to 3, 27 minus 27 minus 27 plus 27. Yes, so n minus 3 is a factor of this expression. So let's divide it now. Minus 9n plus 27 divided by n minus 3. So we get n square first. So n cube minus 3n square minus plus everything on. We are left with minus 9n plus 27. Follow it up with minus 9. So minus 9n plus 27. This becomes plus, this becomes minus, everything on. So the expression that we're dealing with is n minus 3 and n square minus 9, which can further break down as n minus 3, n minus 3 and n plus 3. So if you were to break it up, the graph will show like this. You have minus 3 and you have plus 3. Hopefully you can see there are just two roots. Despite it being a quadratic, there are just two distinct roots. The portion after 3 is of course going to go up, but because there are two roots lying at 3, the graph would look something like this. The graph would look something like this. So for how many positive integers n is this expression less than equal to 0? Only at n equal to 3. Only at n equal to 3, and therefore the answer to the question is 1. The area enclosed in square units by the lines y is equal to x minus 4 mod plus 5 and x equal to 4. The x-axis and y-axis is equal to. Okay. The simplest line to draw are x-axis and y-axis. We have done that. Now let us draw this. If you were simply drawing an x minus 4 mod, it would be at 4 and a V-shaped line at 4 with a slope of 1. But because it is plus 5, it will go up. It will go something like this. This is 5. This is 4. Now look at this. The value, the coordinates here are 4, 5. We are moving at the rate of 1. Where will it cross the y-axis? It will be at 0, 9. It will be at 0, 9. Knowing this is useful. And then you have x equal to 4, which is as good as this line now. So when they're asking me to find out the area enclosed by the lines y is equal to this, and x equal to this, and x-axis and y-axis, they're asking me to calculate this area. This here, hopefully you can see, is a trapezium. This length here is 5. This length here is 9. The height between the parallel sides is 4. So the area is given by half into 14 into 4. Sum of parallel sides, distance between the parallel sides, cancel, cancel. You get your area as 28 or option C. Next, in how many points do the line y equal to 3 and y equal to x square minus 8x plus 12 meet? Okay. Fun thing, this mod functions are impressive. Can I break this down as x square minus 8x plus 16 minus 4? This is what it is like. Now if it had only been x square minus 8x plus 16, it would have gone like this, crossing it at 4 at point 4 at x coordinate 4, but it is minus 4. So it will, this graph will get pulled down. We will have something like this. So at x equal to 4, the value of the function would also be 4. But this is not the end of it. This graph is also getting modded. So it will go up like this. It will go up like this. This portion will no longer exist. This portion will become 4. Here it should have been minus 4. I made a mistake. I should have written down minus 4. But after it is modded, it will become 4. Now I have to find out at how many points will it have intersection with y equal to 3. Y equal to 3 will cut it at 4 points. One here, one here, one here, and one here. What are those points? What are their coordinates? That was never asked. It was only asked how many intersection points. Answer is option B, 4. Next, how many integral solutions are there to 7x minus 4y is equal to 321 such that x is greater than minus 30 and y is less than 60. Okay, let's start making cases. 7x minus 4y is equal to 321. Because I now see what I see is this is a 4n plus 1 kind of number. This is a 4n kind of number. So this has to necessarily be a 4. This has to necessarily be a 4n plus 1 kind of number. So x has to be a 4n plus 3 kind of number. If x has to be a 4n plus 3 kind of number, hopefully, given the limit for x, that it is greater than minus 30, the first acceptable value of x can easily be identified. That will be minus 29. The first acceptable value for x can easily be identified. It will be minus 29. So when we have 7 into minus 29, we get minus 203. It goes to the other side. It goes to the other side, minus 203. Why is my pen not working? Okay. It goes to the other side, minus 203. It becomes added. So let me just do 321, 203, so 524. So minus 4y is equal to 524. Cancel. And cancel, I get 131. Y equal to minus 131. This is where our storyline will start. These are the cases where our storyline will start. From here on, our cases will begin. Now, every subsequent case would be obtained by increasing x by 4 and increasing y by 7. So this will become minus 25, minus 124, minus 21, minus 117, and so on, because the amount of increase in x and amount of increase in 7x and increase in 7y has to be maintained. So this will keep on happening. But counting every individual case is going to be very painful. So let us look at the other extreme. The other extreme is y is less than 60. Y is less than 60. How do I identify what is the final acceptable value of y that we can work with? Can you see? This is a multiple of 7 minus 4y is equal to 321. So how much is it? 280 plus 41. This is 7n plus 6. This is 7n plus 6. So this has to be 7n plus 1 from a multiple of 7. If I remove a 7n plus 1 kind of number, I'll be left with a 7n plus 6 kind of number. 280 plus 41. Yes. So this is 7n plus 4. Now I have to identify some multiple of 4. Some multiple of 4 that is just one more than a multiple of 7. Some multiple of 4 that is just one more than a multiple of 7. Hopefully you can see y has to be 7n plus 2 kind of number. If you're able to see y has to be a 7n plus 2 kind of number under 60, the largest 7n plus 2 kind of number is 58. In fact, you can directly reach that expression all over again. Let's say 4y is 4 into 58 will be how much? 232. So 7x is equal to 321 plus 232. So adds up to 7x is equal to 553 or x is equal to कितना हुआ 579. So we found one extreme, we have found another extreme, we have found all sorts of things. We found all sorts of things, everything. In fact, you can even skip over this question. You can directly see what remainder does it leave with 7. What remainder does this number leave with 7? Can you see it is leaving a remainder of -5? 126 is a multiple of 7. So minus 131 will leave a remainder of -5 or a positive remainder of 2. So positive remainder of 2, you can directly jump to 58 under 60. Now we have to count how many cases are here. Now, hopefully you can see, minus 29 to 79, it is moving in steps of 4. Minus 131 to 58, it is moving in steps of 7. So either you use this or you use this, whatever your choice is. I'm using X is, can I say, if I add 33 to this, it will turn to 4. If I add 33 to this, it will turn 8. If I add 33 to this, it will turn 12. If I add 33 to this, it will turn to 112. How many numbers do we have here? In this table? This is simply a table of 4 now. There are 28 such numbers. So how many integral solutions are there? 28 solutions. You can also go ahead and check it for y's. 131, if I increase it by 138, it will turn to 7. If I increase this by 138, it will increase to 14. If I increase this by 138, so this will turn to 196. These are all multiples of 7. How many multiples of 7? 28 of them. Regardless of how you count, you will definitely reach 28. See, this question, although is classified as algebraic in nature, the way this question is done or the way this question should be approached is so, let's call it how much, is so number theory based also you can do it, ratios based also you can do it, even algebra based, this APGP understanding algebra based. This question is not limited, and ideally you should know all different ways of handling it. Hopefully you learn it. Last question, if P plus Q is equal to 2 and PQ into PQ minus 8 is equal to 25, find the value of P raised power 4 plus Q raised power 4. Okay. If I need P raised power 4 plus Q raised power 4, I'll square this and I'll square it again. That is all I can do. So let me go P plus Q whole square is equal to 4. So P square plus Q square plus 2 PQ is equal to 4. Okay, let me take it to the other side. Now I have P square plus Q square whole square is equal to 4 minus 2 PQ whole square. So I get P raised to the power 4 plus Q raised to the power 4 plus 2 times of P square Q square is equal to 16 minus 2 into 4 into 2, 16 PQ plus 4 P square Q square. Okay. So I can get rid of this 2 P square Q square with 2 on the other side. And now you can also pay attention to this expression. This expression is as good as P square Q square minus 8 times PQ. If I took out 2 PQ common from here, are just 16 minus 2 times PQ. Would I be left with, sorry, if I take out plus 2 PQ common from it, would I be left with PQ minus 8? And this is what is given to us in question. So this is as good as 16 plus 2 into 25 or 66. The answer to this question should be option B. Hopefully you learned something. That will be all. Okay, bye.